Acid-base disturbance. In this chapter, we're going to go through concept of acid-base disturbance, acid-base parameter, and arterial blood gases, clinical acid-base disorders, pathogenesis of acid-base disorders, and influence of acid-base disorders. Before we talk about disturbance or imbalance, let's talk about the concept of acid-base balance first. As I mentioned many times before, if you're going to talk about disease, you ought to know what is health. And you're going to talk about what is abnormal, like in pathology we did last semester. You need to know what is normal. That's why before we learn pathology, we learned histology and embryology plus anatomy. So we know from a morphological point of view what is normal, what is abnormal, can be decided very easily with the normal structure as the standard. So here, it's the same thinking pattern. We need to know the concept of acid-base balance and how the balance is maintained. Then we can talk about what can disturb this balance. Acid-base balance refers to the mechanism of body uses to keep its fluids close to neutral pH, that is neither basic nor acidic, so that the body can function normally. Arterial blood pH is normally closely regulated to between 7.35 to 7.45. Please keep these red words in your mind, and this might be the answer of questions in quizzes. Acid, any ionic or molecular substance that can act as a proton donor to provide. A proton donor is the structure to provide proton. We call it acid. We have strong acid and weak acid. And the strong acid, you can see here, I've listed here. HCl, H2SO4, and H3PO4. And the weak acid is much weaker than the strong acid. Imagine if we have HCl splashed on your skin, what will happen? You've all learned chemistry, right? Okay, now let's move on to bases. Any ionic or molecular substance that can act as a proton acceptor, we call it base. Strong alkali and weak alkali. And by looking at those formulas, you know better than me which one is strong, which one is a bit weak. And the origin, where the acids come from. We have intracellular metabolism that can produce acid, volatile acid. For example, it's a combination of carbon dioxide and water can produce this weak acid. And fixed acid, lactic acid, ketone bodies, sulfuric acid, and phosphoric acid. These are all fixed acid. And the origin of bases, we have less origin of bases. So you can imagine our body can produce more acid, so many ways to produce more acid compared with bases production. And how acid and base balanced in our body. Let's pay attention to pH first. What's the normal range? Review it, please. ECF, we're all very familiar, we're all very good at. It stands for extracellular fluid. pH of extracellular fluid is between 7.35 to 7.45. Deviations outside this range affect membrane function, alter protein function, etc., etc. We can't survive with a pH less than 6.8 or higher than 7.7. When it's less than 7.35, we call it acidosis. When it's higher than the upper limit, 7.5, 7.45, we call it alkalosis. Alkalosis. Central nervous system function deteriorates, coma, cardiac irregularities, heart failure, periphery vasodilation, and drop in blood pressure can happen when acidosis and alkalosis exists in our body. Given that normal body pH is slightly alkaline, because we learn in chemistry the neutral one is 7, and when it's between 7.35 to 7.45, it's slightly alkaline, right? And that normal metabolism produces acidic wastes, products such as carbonic acid, carbon dioxide reacts with water, and lactic acid. Body pH is constantly threatened with shifts towards acidity. Like I mentioned, the origins of acid and balance. We have much more origins of acids than the origin of bases, yes. In normal individuals, pH is controlled by two major and related processes, pH regulation and pH compensation. Regulation is a function of the buffering system of the body in combination with the respiratory and renal system. This is very important key two systems that contributes a lot to the balance of acid and bases. Whereas compensation requires further intervention of the respiratory and or renal system to restore normalcy. Okay, the proton donor and acceptor or receiver. With our extracellular fluid, we have buffers and RBCs contribute to this. And in our lungs, we have respiratory control. So we can turn the weak acid into carbon dioxide and exhale them out. And in intracellular fluid, the proton and the all of a sudden, cat got my tongue. K stands for the exchange between these two